In this video, we're going to look at finding the sum of a finite number of terms of a geometric series. And in doing so, we get a formula where the sum of a finite number of terms for geometric series is equal to the first term times 1 minus r to the n over 1 minus r. And so that's the formula we're going to be used for finding the sum of a finite number of terms. All right, let's look here at this first problem. We want to find the sum from 1 to 7 for the geometric expression -2 times 6 to the n minus 1. Now, if I had a calculator, I could evaluate this very easily. However, it doesn't match one of our summation formulas in a previous video. So in order to do this by hand without writing out all the terms, we'd have to use the summation formula we just discussed. So to find the sum of a finite number of terms, so Sn is equal to a1 times 1 minus r to the n over 1 minus r. Well, looking in this form, r is going to be 6. A1 is going to be what I get in when I put in this index number first. N for n, so if I put 1 in, I end up with the first term of -2. So the sum of the first 7 terms is going to equal -2 times 1 minus 6 to the 7th power over 1 minus 6. And then we would evaluate that. So we would get -111,974. All right, let's look at this next one. So I want to evaluate the sum with this information that's given. So we're geometric, first term 64, so the last term of this series would be 1/4, common ratio is 1/2, and I want to add up all the numbers together. Well, without generating the entire series to add together, what we're going to have to do is we're going to see what part of our formula we're missing in terms of the information. So the sum of finite number of terms of a geometric series equal to a1 times 1 minus r to the n over 1 minus r. Our issue is we don't know what n is. To figure out what n is, we're going to have to use our explicit formula here and say that an for a geometric series is equal to a1 times r to the n minus 1 power. Well, an is 1/4. We know that a1 is 64. We know r is 1/2. And we don't know what n is. And so we'd work our way and try to solve from here. I divide by 64. We're going to get 1 over 256 is equal to 1/2 raised to the n minus 1 power. And then we work our way and we solve from here. I could solve this by using like-based properties. 1 over 256 is the same thing as 1/2 being raised to the 8th power. And so I can say 1/2 to the 8th power is equal to 1/2 raised to the n minus 1 power. I could use the properties of, solve this by using some properties of exponents here and avoid having to use logarithms. And so I rewrite both sides as 1/2 raised to a power, and then I set the exponents equal to each other, and that lets me solve for n, and so I get n to be 9. Now I have all of my information, so we're basically looking to find the sum of the first 9 terms of a geometric series, which is going to equal 64 times 1 minus 1/2 raised to the 9th power over 1 minus 1/2, and then we would evaluate that. And we wind up getting 127.75. All right, let's say I want to determine the number of terms in each geometric series with some given information here. So looking at this problem, I'm given the summation form because I see sigma. So we're adding a certain number of terms from I is equal to 1 to n, and the sum is -160. So that -160 is Sn. Now, in my formula, I need to know a1 and r. Well, r is going to be 3. a1 is going to be what I get when I put in 1. Put 1 in, we get -4. And so I'm going to plug everything into my finite sum formula. Sn is equal to a1 times 1 minus r to the n over 1 minus r. So we have -160 is equal to -4 times 1 minus 3 to the n power over 1 minus 3. And then we work our way to solve. So I would divide by -4 first. And then we're going to turn around and we're going to multiply by -2. So we get -80 is equal to 1 minus 3 to the n power. We're going to subtract by 1 and divide by a negative. So we end up with 81 is equal to 3 to the n power. Now, I could solve this by using like exponent properties here again, because 81 is 3 to the 4th power. So I got 3 to the 4th power is equal to 3 to the n, and that's going to tell me that n is equal to 4. All right, next one. So I'm given the first few terms in a geometric series, and given that the sum is equal to -1,562, I want to know how many numbers did I add together. Well, I'm going to start identifying information. A1 is going to be -2. R in this case is I'm timesing by 5 every time. And so our summation formula S of n is equal to A1 times 1 minus R to the n over 1 minus R. We plug in the information that we're given. So -1,562 is equal to -2 times 1 minus 5 to the n power over 1 minus 5. And then we work our way to start solving. So I'm going to start by dividing by -2. We get 781 is equal to, I have 1 minus 5 to the n power over -4. I'd multiply by -4. It's going to give us -3,124 is equal to 1 minus 5 to the n power. I could subtract by 1 and then divide by a -1. And we have 3,125 is equal to 5 to the n power. Now, you could take a natural log of both sides and solve, or I could look to use exponent properties and figure out 5 to the what power makes 3,125, and that is 5 to the 5th power. So 5 to the 5th power is equal to 5 to the n, and so that means that n is equal to 5.